Tool designed by Network Optimization. OptiNetDB RF database. Developed by Mauricio Cabrera.
Artlist.io.
OptiNetDB is a specialized database for the detailed collection of information about Nuvitel's RF access network. This platform records specific aspects of each network cell, including technologies and configurations, and integrates coverage simulations and drive test route measurements to improve planning and optimization. The latest update of OptiNetDB has added key network KPIs, providing additional tools to analyze and improve a network efficiency and reliability. In short, OptiNetDB is instrumental in driving the construction and maintenance of an efficient and reliable network. How OptiNetDB works. OptiNetDB is a PostgreSQL database that centralizes RF access network information. The XML data from the OSS, coming from the provider's platforms, is processed by a Python script that converts it into text and loads it into OptiNetDB. In addition, a terminal application for loading, reading, updating and deleting cell data via an Excel template designed for external users is being developed and is nearing completion. Apache Airflow is responsible for extracting, transforming, and loading key KPIs from the new performance database for future analysis in conjunction with OptiNetDB data. The visualization of these KPIs is done through Apache Superset, a business intelligence tool that facilitates the sharing of dashboards with groups of users via a web platform. For optimized geospatial visualization, OptiNetDB integrates with QGIS, allowing visual analysis of coverage simulations, cell locations, and drive tests. In addition, as OptiNetDB is a database, engineers with knowledge of SQL queries can perform detailed analysis of the stored parametric information, including site-specific parameter audits for new sites and ensure compliance with network standards. Presentation of the functionality of the tool in action. Update, cell information. We will now explain how OptiNetDB works. In the latest version of OptiNetDB, user authentication has been incorporated to improve access control to the platform. Once the user is logged in, a template will be downloaded for the cell update. This template includes the table format with the minimum information required for cells information.
Music licensing reimagined.
Then, we will proceed to select the technology, the cells, and the table field to be updated. It is important to note that the column border_cell will be without data.
Artlist.io.
Subsequently, we will run the update new data to that column. This will be done by selecting the corresponding option and specifying the path of the modified template. Finally, the update will be executed in the database as you can see. Parser and load cell parameters. The cell configuration files of the vendors, Nokia, Huawei, ZTE, are extracted from the vendor's OSS systems in XML format and stored in folders in Nuvitel's FTP repository. To obtain the network parameters in .csv text format, we carry out the parsing process of these files using a JavaScript executed from the Python terminal application. Once the files have been parsed and converted to text, they are ready to be used and loaded into OptiNetDB. OptiNetDB stores the parametric information of the grid cells, maintaining histories. This means that we can make comparisons in case of degradations due to parameterization failures.
Artlist.io.
KPIs measurements ETL Apache Airflow. Using Apache Airflow, we coordinate the extraction of key access network performance data from the new performance database for subsequent use in OptiNetDB. Apache Airflow provides its own process manager, facilitates the supervision of the execution of these tasks.
Music licensing
These tasks are scheduled in Python code, which offers flexibility and allows for more efficient workflow management. Geodata visualization, cell information, QGIS. We have integrated OptiNetDB with QGIS, which allows us to visualize geo-referenced cell locations. OptiNetDB performs the geoprocessing in PostGIS to enable this visualization. QGIS can connect to OptiNetDB via a database login, allowing us to work with geographic cell data according to technologies or carrier. All this information has been generated using OptiNetDB's internal data. The platform provides tables with basic and parametric cell information, which is essential for network optimization and planning processes. In the following, the selected cell information tables are presented, first for LTE and then for UMTS. Geodata visualization, simulation, QGIS. In OptiNetDB, we can upload network coverage simulations, which can be used by other services, such as QGIS, to visualize the coverage of geographic sites. In situations where no field tests, drive test, exist in a specific area, these simulations serve as a crucial reference to assess the coverage status and plan optimization works. Geodata visualization, drive test, QGIS. Drive test measurements can also be loaded into OptiNetDB and visualized in QGIS for coverage analysis and optimization moves by changing azimuths or cell tilts. OptiNetDB allows the loading of various data types, such as RSRP, PCI, RSRQ, among others, which expands the possibilities for network analysis and optimization. KPIs visualization. Apache Superset. Apache Superset is an open-source business intelligence tool that allows sharing dashboards with users or groups of users. On this platform, we will create dashboards for network analysis by querying the OptiNetDB. Initially, we will focus on KPIs and then we will generate other types of reports that will allow us to cross-reference parametric information for optimization purposes. In this report, LTE KPIs are presented at region, site and cell level, providing a detailed view of network performance at different levels of granularity. SLQ query to OptiNetDB. OptiNetDB offers the flexibility to build SQL queries, allowing optimization engineers to extract the parameters needed for their audits or analysis. An example of this is the comparison of baseline design parameters with the parameters configured in a new expansion, which facilitates parametric auditing. In the area of optimization, potential flaws in commissioning configurations that could degrade cell performance can be identified. In this case, an SQL query in OptiNetDB was used to generate audits. Our primary objectives: 1. Historical data repository. Create and maintain a historical database of network parameters essential for optimization processes.
Music licensing
2.
reimagined.
Parametric change validation. Verify and track parametric changes within the GSM, UMTS, and LTE access networks. 3. Geospatial visualization. Enable graphical presentation of cell information in GIS tools, Geographic Information System, providing access to fundamental network data. 4. KPIs visualization. Create dashboards dedicated to tracking key KPIs in order to effectively monitor the status of the network. 5. SQL query generation. Generate SQL queries to extract network parameter data in formats required by optimization engineers. 6. Parameter monitoring. Continuously monitor network parameters for accuracy and performance. The database promises to optimize our processes and increase our productivity. We appreciate your attention during this presentation and look forward to working together to make the most of this tool. Thank you.